Okay, so again, my guess is that you know, already have been presented with this concept of slope of a line, right? What is the slope of a line?
Like how much it goes down or up.
Okay, is how much it goes down or up? Anybody else got a different word for it? I always, if I'm trying to describe it like in a non-mathematical way, I might just say it's like the tilt. It's the tilt of the line, right? Every line, you know, is going, it's tilted some way or the other, and that's really what we mean by the slope. So in the last lesson, we used 2 points, x and y intercepts, to graph a line. Another way is to use 1 point and the slope. The slope, the concept slope, is the measure of how much it's going up or down from left to right. Right? It's important, you know, as you're looking at it from left to right, what's it doing? So, find the slope of a line that goes through the points negative 4, 2, and 2, 6. Right? So we know how to plot points. That was lesson 1. We connect them with a line because we know that 2 points uniquely determine the line. And now we have to come up with some kind of a measure of what's it doing. I mean, is it going up or down, first of all?
It's going up.
From left to right.
It's going up.
Yeah, so if you start at this point on the left and you go this way, it looks like it's going up. Right? So in that direction, it's definitely going up. Okay, so in these first few problems, which you don't have to do it this way, but you might find it useful, we're going to draw a triangle. You know, draw a triangle, and you could make it down here, or you could make it on top. I'm going to do it up here. This triangle connects those 2 points, and it helps us to see just how much is it going up and how much is it going to the right, from left to right. Okay, well, how many units did it go up? From here to here, how many is that? It was 4, right? How many units did it go to the right?
6.
Right? I mean, you can just count it, guys. Hunter, right? That's 6. Okay, so with that, we can quantify how much was it going up as it went over. And you've heard this before. Slope is the rise over the run. Which one of those do you think represents the rise? The 4 or the 6?
The 4.
The 4 is a fairly obvious, that's the rise. Maybe the run being that the across isn't quite as obvious, but we know that the rise goes on top. So 4 divided by 6. And can you simplify 4 over 6? 2/3. So you definitely want to do that. Okay, let's try it again. 5, 2, and 4, negative 1. First, we plot the points. 5, 2, and 4, negative 1. Let's go. It's not mine. Okay. So we do that, right? I can connect. Let's draw the line just because we can. Should have arrows on both sides. Looks like something like that. Then I can make a triangle. Again, I'm doing the triangle in the upper right. You don't have to, but okay. So how much is it going up?
3.
Looks like 3. And how much is it going to the right? 1. So you would say that the slope is the rise divided by the run, which is 3, right? When you see the number 3, right, without a denominator, that means 3 over 1. Okay, you guys try now. Try to find the slope of a line by plotting the points, drawing a triangle. Find the slope between those 2 points. Okay, so first you plot the points. Negative 2, 3, 4, 6. Draw the line. Okay? And then how much are we going up? How much did we go up?
3.
How much did we go over? 6. So the slope is what divided by what?
3 divided by 6.
3 divided by 6, which can be simplified?
So 1/2.
1/2, right? And don't turn them into decimals. You really want them to be fractions, because when we use them to graph, we really need them to have whole numbers in the numerator and denominator.
Got it.
Okay. Next. How many remember this formula?
I do.
More or less. Okay?
I don't. I hate it though.
So this formula is a way to calculate the slope without drawing the graph of the line, without making a triangle. You plug in for the x and the y coordinates of 2 points. Okay? The way you write this, right, when you write y with a little 2 to the bottom right, that's called a subscript. Right? Sub like submarine, it's a little bit lower. It's not the same thing as saying x with the 2 above, that's x squared, right? So x with a 2 on the bottom is called, you can say it different ways. The book says, right, say x sub 2. I would say x2, x1, x2. So we're going to get 2 points, and we need to label one of them will be our first point, x1, y1. The other one will be our second point, x2, y2. And then we just substitute and calculate. And especially now, because we've got the fraction format in the calculator, we should be able to get these mostly right.
I remember this one.
Okay, so now we're going to use the formula to find the slope of the line that passes through the points, -4, 2, and 2, 6. Okay, so we need to say which one of these points is the first point and which one is the second. Most of the time you're just going to say the first one is this one. So this is the x1, y1. This is the x2, y2. Right, the formula is y2 minus y1 divided by x2 minus x1. So we should just substitute for all 4 of those letters. The y2 is here, it's 6. The y1 is 2. Right? The x2 is 2. And the x1 is -4. That's minus a -4. Now, at that point, you can put that in your calculator right now, right? Without trying to do any of the simplifying yourself. Just go to the calculator, bring up the fraction format, right? Alpha, y equals 1, 6 minus 2, 2 minus -4. So just put it in exactly like you see it, and when you hit enter, it's gonna do the math, simplify the fraction. It's all done, right? 2/3. Yeah. Sure. Okay, here we go. I'm going to do another. This is not a you try. This is me try. Okay. And again, this one has fractions involved. So some of the coordinates are not whole numbers. It's still, I got to name one of these points x1, y1, the other one x2, y2. Does it matter which one is x? In the end, it doesn't. As long as you're consistent the way you subtract, it'd be the same. Like somebody might say, well, I'm going to do sorry, that was wrong, clear. I'm going to do -3 minus 5 in the numerator, and I'll do 1/2 minus 9/2 in the denominator. But somebody else might have reversed the order and had 5 minus -3 divided by 9/2 minus 1/2. So how about somebody on that side of the room do the one on the left, or on the right, and this side of the room do the one on the left. Use your calculator and see what you get for those two. Just show that it's actually the same, whether you reverse the order or not. Nine over 2. Now this time you got fractions inside of fractions. Who got an answer? Jackie, what'd you get? 2? On this side. You got a 2 over here. Okay? What about on the other one? This side of the room. Did you do it, Felicity? And so you got a 2. So in either case, it doesn't matter which one is your first point and which one is the second point. Here's what you can't do, right? You can't say, I'm going to go -3 minus 5 in the numerator and then do 9/2 minus 1/2 in the denominator, right? You just can't mix them up. You got to do it in the same order. As long as you do it in the same order, you're going to get the same thing every time. Okay. So you try. Use the formula to find the slope between those 2 points.
I did not say that. I did not say and it was just a joke.
Okay? So that's how you use the formula to calculate the slope. If you really find it useful to draw the points and draw the triangle, then by all means do it. I mean, you could do that. But remember, like at this step right here, once you've plugged in for all those numbers, use the calculator, right? And then you won't have any mistakes about the arithmetic if you just get the numbers in the right places. Okay, let's try. Okay, there's another you try. Do this. So you try. Plot the points, connect them with an infinite line, and then use the formula. So this is going to be some graphing and some using the formula to calculate a slope. I think these are new points.
-1 minus 5.
So the slope is -2, right? It's negative because the line is going down from left to right. As you look at it, it's going down. Right? Up is like this, down is like that. Yeah. Yes, you got homework tonight. No, everybody gets the email. Okay, quiet. So there's the slope should be -2. Okay, so a line that has a positive slope means it's going up from left to right. A line that has a negative slope means it's going down from left to right. What would you say then about a horizontal line? It's not going up and it's not going down, so what would be the slope? Neutral, which would be, think of it like this, right? If a line's going up from left to right, that's positive, right? If a line's going down from left to right, that's negative. What's exactly between negative and positive numbers on a number line? 0. So this is m equals 0. So, and remember, this connects then with something we did before, which was, how do you write the equation of that line right there? Y equals 3. It's 3. A horizontal line is y equals a number. What number is it? The y-intercept, which is 3. So this is y equals 3, and the slope of the line is 0. So you got to remember that about horizontal lines. It's always y equals a constant, and the slope is always 0. So what do you think about a vertical line then? Hunter, is that you? Okay, turn it off. Okay. Next time you're losing your classwork credit, interrupting the class. Okay, so what about a vertical line then? You going to say its slope is 0? Are you going to say the slope is 0? Okay, so try to think of it like this. We said that the slope is how much it's going up or down as you go from left to right. Okay, does a vertical line go from left to right? It doesn't. So the definition like that doesn't even make sense. The slope of a vertical line is undefined.
Is that what would be the answer?
Yes.
Okay.
Undefined, right? And we could show that by using the formula. Let's say I take 2 points. I mean, any 2 points on that line we said are good. How about I'll take that point. That point is 3, 2. And I'll take this point. That point is 1, 2. And then I'll plug it in the formula. M equals, I got that wrong, don't I? I got it exactly backwards.
Mr. Callahan?
Yep.
Have you ever heard of Mr. Slope Man?
No.
It's a picture of like a guy, and it helps you remember like that's undefined.
It's called
Oh, really?
What is it called?
That's easier.
It's like I can draw this.
Okay. Okay, quiet. Okay. So if I do this math here, 3 minus 1 in the numerator gives me a 2, and 2 minus 2 in the denominator gives me a 0. What is 2 divided by 0?
0.
Put it in your calculator.
1.
Put it in the calculator. I'm serious.
It's error.
Then do it. Do it.
Well, no, it's down and then it's like that. Error.
Okay? I guarantee you are going to make mistakes on this. Right? You got to be paying attention. If you put in the formula, you're dividing by 0. You can't divide by 0, so it's undefined. Okay, what's the equation of this line?
Undefined.
Remember, the last one was y equals 3. So what would this one be?
Y equals error.
X equals 2.
Oh,
The equation of the line.
You look at the foreign village person.
That's what he's talking about.
Okay? That's cute, and I'm not interested in it, okay? Childish little things like that are not going to get you anywhere else. Okay? You do what you want. I'm not teaching with a little silly figure, okay?
That's just how I learn this stuff.
Okay?
It's okay.
Then keep on going. Imagine you'll get 100 on your test. Okay?
I can tell that's
Quiet. So plot the points 3, 5, and 3, 1. 3, 5, and 3, 1. Connect them with the infinite line. And then calculate the slope using the formula. M equals. Okay, and I'm using these points here. 5 minus 1 divided by 3 minus 3. M equals 4 over 0, which is undefined. Okay, you try this one.
Somebody wants me to do it. I just don't want to do it.
What was that?
Oh, I know we could have. Okay.
Trash? Oh, the zeros and one. What was that? I got two.
Tie.
Okay, so you should have got it 0. The minute you draw the horizontal line, you don't really need to calculate because you know horizontal line is always 0, right? It's not positive, it's not negative, it's right in the middle, 0. Yeah.
Can I just tell if it's like a 0, and even if it's just like the two y values are the same?
Yes. Okay, so another line which they don't actually tell us to look at, but it is kind of important to understand when you're talking about the values of slope. A line with a slope of 1 is this line right here, which we'll learn in a little bit. That's actually the line y equals x, right? Because, you know, every x coordinate equals every y coordinate. 1, 1, 2, 2, 3, 3, right? That line goes exactly in the middle of the first quadrant. I mean, how many degrees are there between the x and the y-axis? Meaning, what's a right angle? 90. So this is cutting it in half. It's actually 45 degrees. That's the line with a slope of 1. Okay, a line that has a slope which is greater than 1 should be tilted up more. Okay, that's greater than 1. That's less than 1. So, I mean, it should make sense to you, like you're graphing a line and it has a slope which is less than 1. I mean, you should be looking for a line that's like closer to the x-axis than it is the y-axis, let's say. So those 3. That's 1. That's greater than 1. That's less than 1. And that's the lesson.